The topic for today is electric current and the theory behind the electric current. So the very first thing we need to review is what are conductors. And you can see that I have copper over here and it has a ton of electrons, but all of that doesn't matter. What matters is the one in the valence shell. So conductors have 1, 2, or 3 electrons in the valence shell, and that is the most important part about them. Now the question is, what happens when you have a metal, a pure metal or an alloy, it doesn't matter. So the electrons inside the metals are shared in something called metallic bonds. And we've talked a little bit about bonds last time. I've talked a little bit about very different. So in covalent bonds, 2 atoms between themselves were sharing a pair of electrons. Metallic bonds are completely different. So what you have is you still have sharing, but now it's not just 2 atoms, it's all of them are sharing the electrons. So how does that work? So what you have over here is you have a bunch of positive ions, and those little minus signs that you see are the valence electrons shared between them. Now I want this to be absolutely clear. These positive ions, they are not just the nucleus. If you look back at the copper, those positive ions are everything, including all of these electrons, except the valence electron, okay? So because it's missing, say, 1 electron or 2 electrons, because it's just missing the valence electrons, right? And we can consider the positive ion, but it's in no way am I saying that all of these electrons are shared. No, just the valence ones, okay? So what you have is a bunch of positive ions, right? You have a bunch of atoms. And the electrons, the valence electrons, they are very loosely attached to each atom. The reason for that is the energy that it takes to remove each individual electron is so low that every once in a while, the ions just don't have them. And this results in a situation where you have an electron, for example, this one, that at first spends a little time with this atom, then it hops over and spends some time with this atom, and then maybe with this one, and then this with this one. So they keep moving between the atoms and hopping from atom to atom in this completely random fashion. So they don't really know where they're going. They don't really have any destination in mind. They just hop between the atoms randomly. So this basically creates a situation where the electrons do not really belong to any particular atom. They just hop from atom to atom. They might belong to an atom at a single point in time, but not permanently. So another way of saying this is an electron sea model. And what we're talking about is we have little islands, and those are our positive ions or atoms, if you will, right, in the sea of electrons, and the electrons hop from from island to island. Another way of calling electrons is also electron cloud, right? Because electrons, like I said, they don't have a set orbit. They just hop between the atoms like any way they like, and they're in constant movement. Actually, or atom constant. Okay. So in this case, they're not zooming around a single atom, they're zooming around as many atoms that they can figure out. So what happens when we actually have an electric current? Well, let's take a look. To get an electric current, you need to get all of those electrons to move in the same direction. Now remember, over here you have electrons and they're all moving, but they're not moving in the same direction. Maybe this electron is moving this way, moving the other way, and the third electron is moving up, and the fourth electron is moving down, and then you have electrons moving left to right, and then you have electrons moving in any way you can think of, right? So when you have an electric current, they're all moving in the same direction. How can we possibly achieve that? Well, the best way to do that, and the only way to do that, really, right, is to apply a big positive and a big negative charge. So this is what happens, right? You have a big positive charge over here. Because it's positive, it attracts the electrons because they're negative. On the other hand, on the other side of your conductor, you apply a big negative charge, which in turn repels the electrons. So each electron basically gets like a double whammy, right? On one hand, it is attracted by that big positive charge. On the other hand, it is repelled by the big negative charge, and it's pushing it along in the same direction towards the positive charge. And this is what you're seeing over here. So this is a representation of an atom, and those positive charges, they're basically your proton. Okay? Now you can see that you have fixed electrons over here, right? Those are your electrons that are not in the valence shell, right? And you can see that once you apply this big positive and big negative charge, and yes, it's a battery, you know, the plus and minus side on the battery. You literally grab a wire, put a piece of wire to the plus, the piece of wire, the other end of the wire to the minus, and this is what happens. Okay? So what you have is electrons literally hopping from atom to atom, but they all move in the direction of the plus. Okay. So the next slide, this is very important, okay? This is one of the most important definitions you will have in my class. Now, we are not in person right now, we're still doing the online instruction, but once we are in the classroom and you are taking tests, I can guarantee you every single test will have this definition, because this is one of the most fundamental and important things to learn in math, because it is useful. So the definition of electric current. Electric current is a flow of electrons, charge, through the conductor. Now, we do need to unpack this a little bit, okay? The first and the key word over here is through. Okay, remember, electrons flow all the time, but all electrons move in a different direction, so you cannot say that it's flowing through the conductor, right? When you have the electron C situation, your electrons are moving around the conductor, right? They're moving inside, but they're not trying to get through anything. Now, in this situation, you literally have a bunch of electrons trying to move to the positive charge. In other words, they're moving through. So the key thing to remember, right, that this word through tells you that all electrons must flow in the same direction, okay? The other important part is, of course, the conductor, right? If you don't have a conductor, you don't have a flow. Basically, the electric current depends on two things, right? The availability of those electrons. In other words, do you have a conductor, right? And the other thing it depends on is whether or not you have your big positive and negative charges, right? If you have something driving the electrons through. So the conductor is the important part as well. Don't forget that. Now, the next one is electrons or charge, right? In our class, it will always be electrons that are moving, okay? However, it is possible to make ions to move as well, because when you have positive and negative ions, you can absolutely, you have some kind of solution, right? Maybe you have something dissolved in water. This is why when you have, when you do little experiments and try to conduct electricity, pure water doesn't conduct, but once you mix in some salt in there, that gives you positive and negative ions, you have an electric flow. So you can absolutely make ions flow just like electrons do. But this is not really convenient for us for our class. But you should know that this possibility exists, and the most common application of this I see in the real life is when we have another flood and there is a downed power line that is lying in a puddle or some kind of water, and people step into that water and get electrocuted, right? So the current that is flowing in that water, chances are that's actually ions and not necessarily electrons. Something to keep in mind. Okay, so now that we have unpacked this definition, please, please, please memorize it, right? Everything about it is important. It is a flow, right? The electrons all going of electrons through, as in they're moving in the same direction, the conductor. You have to have a metal.